We just finished binary compounds, type 1, 2, and 3. So now we're going to start talking about compounds that have more than two different elements. This is where we get into polyatomic compounds, and primarily those with polyatomic ions. So a polyatomic ion is something that has a charged entity. So we see here a charged entity with several atoms bound together. So it's a group of atoms that has an individual charge. And now these groups of atoms with charges must be memorized. So this here is the table of polyatomic ions that you must know, especially for that quiz on October 11th or 14th, depending on the class. So the best thing to do with this is to make flashcards or just straight up memorize these polyatomic ions. Notice the different names. So for example, we have nitrate and nitrite. Nitrite is NO2 1 minus, nitrate is NO3 1 minus. The charges are the same, they're both a 1 minus, but the number of oxygens is different. Our ite has one fewer oxygens than the ate. So it's good to know these names because this will come in handy when we start talking about acids. So this here is an example of a polyatomic ion, ammonium acetate. The rules for naming these are still very similar to our binary compounds. The cation comes first, so we have NH4+, then the anion, our acetate, C2H3O2-. But if you notice, the overall charge of the compound is still 0. So we had a +1 ammonium and a -1 acetate to give us an overall charge of 0. So here are some more examples. We have sodium hydroxide, magnesium nitrate, ammonium sulfate, and iron 3 phosphate. Now notice that when we had our iron right here, which still had the transition metal, so we could have more than one charge, we need to indicate the charge with our Roman numerals. And if you look at magnesium nitrate, we needed 2 nitrates, because that's a 1 minus, in order to cancel out our 2 plus on magnesium. So here is a flowchart for naming our polyatomic compounds. First we ask ourselves, is it a binary? Yes, then we go back to our type 1, 2, 3. If no, then we ask ourselves, is there a polyatomic ion present? Now you would recognize that ion because you will have memorized that table and know all the names. If there is, then it's just very similar to our binary compounds with our cation first, then our anion. So here is an example of that. What is the name of the compound KClO3? The correct answer is B, potassium chlorate. Our ClO3 minus is chlorate because it has more than the ite, and it's just potassium, our cation first. Here's the next question. Which of the compounds below are named correctly? The correct answer is D. Number 1 is the only one named correctly. Now, number 1 here, we had to use our binary type 3 because it's 2 nonmetals, so we had diphosphorus pentoxide, 2 phosphorus, 5 oxygen. Now our number 2 here is chlorine oxide. Now we have 2 nonmetals, so we needed to use that dioxide. Number 3 here, lead iodide, is incorrect because lead, we need to indicate the charge on lead because it is a transition metal. Now last, copper 1 sulfate. The sulfate is not a -1 charge. It is a -2 charge. So we need to have a copper 2 sulfate. Now we're going to go into naming acids, where our acids is going to be any compound with a hydrogen that comes first. So you notice here we have HCl. Our hydrogen is first. So we're going to take our anion and attach a H+ ion to it. here's the simplest type of acid to name. If that anion does not contain an oxygen, we just add hydro and then the suffix "ic." So here we have HCl. So we have hydro, and then our chloric, because of the chlorine, add the "ic," and then acid at the end. So hydrocyanic, here's our cyanide, and then the hydrogen, so hydrocyanic acid, and then hydrosulfuric acid. And here's a table of common acids that do not contain oxygen. These rules apply if our anion contains an oxygen. We add the suffix "ic" if our root name has an 8. So for example, NO3, NO3 minus is called nitrate. So because of our nitrate, we change the ending to "ic." Same thing. Sulfate have 2 hydrogens, we have sulfuric acid. Now we add 2 hydrogens because our sulfate has a 2- charge. And like before, we always want our compound to be neutral, or 0. And lastly, acetic acid. So we had acetate, added our hydrogen, so it became acetic acid. Now same thing, our anion contains an oxygen, but this time instead of ending in 8, it's going to end in ite. And if it ends in ite, we add the ending us, O-U-S. So originally, NO2 minus was nitrite. And because we added that hydrogen, it now became nitrous acid. Same thing, sulfurous acid, and then chlorous acid, because we had chlorite and sulfite. This is a table of some common acids that contain oxygen. Nitric, nitrous, sulfuric, sulfurous, phosphoric, acetic. Now notice that our nitric came from our nitrate, which is NO3, and our nitrous came from our nitrite, which is NO2. So our 8 has one more oxygen than our ite. And finally, this is the flow chart for naming our acids. Does our anion contain an oxygen? If no, very simple, then we add hydro and the ending "ic." So hydro, "ic," acid. If it does contain an oxygen, then we need to look at the ending of our polyatomic ion. If it's ite, it becomes us. If it's, so I hear ite to us, 8 to "ic." So which of the following compounds is named incorrectly? The correct answer is B. Reason why this is named incorrectly is because we have an O2. Remember, oxygen is in group 6, so it is a 2-. So the overall charge for oxygen is a -4. Therefore, we must have a +4 titanium. So it must be a titanium 4, not a titanium 2, in order for us to have a neutral compound.